Okay, here is problem 5 from homework 5. Woohoo! Okay, so this is the percent yield question here, and these look a little different than what we saw in the last one, but you should be able to do all of these by at least by the end of the homework. So of course, always start by balancing. 3 and 3. What is the percentage yield of 56.9 grams of... I always want to call this WO3, but it's tungsten oxide. Yields 41.4 grams of tungsten. I might actually end up calling it WO3, just because that's way too funny. So I'm looking for, in order to find the percent yield, remember percent yield is actual over theoretical times 100%. Okay, so this gives you 56.9 grams of WO3, and this 41.4 grams of tungsten is the actual yield. So using this 56.9 grams of WO3, we need to calculate our theoretical yield. Okay, so this becomes just a dimensional analysis problem. And let me give you a little piece of advice here. Store the molar mass of WO3 in your calculator. Because you're going to use it a lot. Okay, so that gets me grams of titanium oxide to moles of titanium oxide, and then tungsten. And then I want to go from moles of tungsten oxide to moles of just tungsten. And then the final step is to use the molar mass of tungsten to find the moles of tungsten. Okay, so this gives us grams of tungsten, which is what we want. And when you plug this into your calculator, you get 45.1198 grams tungsten. But this asks for percent yield. Okay, and percent yield is actual over theoretical times 100%. And I have, they gave me the actual. And I calculated the theoretical. And that gives me 91.8% yield. Pretty good. Alright, B. How many moles of tungsten will be produced from 3.72 grams of tungsten oxide if the yield is 92%? Okay, so this time they give you the percent yield, and they give you the starting. Okay, and what they're looking for is the actual. So in order to get the units to work nicely, it's saying how many moles. So we want moles of tungsten equals 3.72 grams tungsten oxide, aka WO3. And this is 1 mole tungsten oxide over the molar mass of tungsten 3 oxide. Okay, and this gets rid of my grams of tungsten oxide and gives me moles, and then I just need to do a simple mole ratio conversion. 1 mole tungsten for 1 mole tungsten oxide. Gets rid of the moles tungsten oxide, and gets me moles tungsten, which is what I want. So that's 1.60457 times 10 to the minus 2 moles tungsten. Okay, this is our theoretical yield, but we're trying to find the actual yield. Okay, so when we rearrange the percent yield, we get actual equals percent yield times the theoretical yield over 100%. I get 92.0% is the percent yield given in the problem, times the theoretical yield over 100%. Percents cancel out. And I get, with 3 sig figs, 1.48 times 10 to the minus 2 moles tungsten. Alright, so that's part B. The next part is part C, which is a chemist carries out this reaction and obtains 11.4 grams of tungsten. If the percent yield is 89.4%, what mass of WO3 was used? Alright, so this time we're actually going to start with a percent yield, okay? Because what they're really asking you to do is say you have this mass of tungsten that's actually produced. That's your actual. They give you the percent yield. So what they're asking you to do is take the theoretical yield and back calculate to the mass of tungsten oxide. And that is a lengthy, somewhat, calculation. So the first step is we need to solve the percent yield for the theoretical value, which is actual over percent yield times 100%. That's 11.4 grams tungsten over 89.4% yield times 100%. Okay, the percents go away, and we're left with 12.7517 grams tungsten. Okay, now we've got to do our dimensional analysis step. So we've got question mark grams tungsten oxide equals this 12.75 grams tungsten. Alright, now when I look at this, I see that my compound that I'm given is not the same as the compound that I want. So I'm going to need a mole ratio in there somewhere. But the first step is going to be to get this into moles. So I've got 183.84 grams tungsten and 1 mole tungsten. So that gets rid of the grams tungsten. Now I have mole tungsten. So now I can do my mole ratio. I take that times 231.838 grams tungsten oxide and 1 mole tungsten oxide. that. And my final unit is grams tungsten oxide, which is what I want. And that gives me 16.1 grams tungsten oxide. If you got through all of that, congratulations. Keep working.